Library of functions. These are the basic functions. First one, just a horizontal line. So y equals b or fx equals b. Okay, and you can read the domain of this graph, range, what type of symmetry it has. Okay, it's an even function and it's got y-axis symmetry, etc. Then we got the most popular function, y equals x. It's the identity function, and go through this slowly, take your time. Then a parabola square function, y equals x square, and go through the domain, range, etc. Then we got cubic function or cube function, y equals x cube. It's got origin symmetry, so the function is our function, domain, range, and you can find other information here. Now square root function, a radical function, y equals square root of x. Look at the domain. Domain starts at 0 and positive all the way. 0 is included though. And just read other things. This is, it does not have any symmetry, so it's not even nor odd, so it's a neither. Then we got a cube root function, not that popular, but cube root of x. And now we got absolute value function, like a V-shaped graph. Okay, absolute value function, y equals absolute value of x. We get everything positive above x-axis, and go through the domain, range, symmetry, even or neither. Reciprocal function, so y equals 1 over x. So here positive, first quadrant and third quadrant. So x negative, we get negative values. X positive, we get positive values. So it's y equals 1 over x. And go through the domain, range. Domain is all real numbers except 0, because 1 over 0 is undefined. So you get that. So read through these information. And we got a circle, x minus h quantity square plus y minus k quantity square equals r square, where hk will be the center. In this case, this is 0, 0, but this circle could be anywhere here with hk center and radius of r. From here to here, that's r. And by the way, the circle is not a function because the vertical line test fails. Now, transformation of functions. We start with the parent function, then we just move this around and get another function. So here is, let's say, parent function y equals x square, a parabola. Then when we do y equals x squared plus 4, pretty much we move this whole graph up 4 units. Here is 0, so 1, 2, 3, 4. Just move up like here. Okay, so this is parent function y equals x squared, and now we got a transformation y equals x squared plus 4. So the transformation function y equals x squared plus 4 shift the graph of the function. What does this do? Shifts up function up 4 units. Okay, x squared plus 4. All it does is shifts the original graph 4 units up. Okay. In the same way, x squared minus 3 means the parent function is here, shifts down 3 units, so 3 units downward. So we can generalize in this way. If x plus c, outside plus c or minus c. If c is positive, that means plus c, so shifts up. and it's a C, but like negative, like here, -3, then downward. Okay. Now we are shifting to the right, left. So parent function y equals x squared. Now plus 4, look at here. See, x squared, but plus 4 is inside. X plus 4 is x squared like function. So plus 4 means we have to shift 4 units to the left. So shift left. Okay, plus 4, do not think it's plus 4 means right side. No. To make inside 0, we have to put x equals -4. So that means we have to move left. In the same way, x minus 3 squared, -3 inside, so shifts right. Okay, shifts the graph of the parent function left. How many units? 4 units. Here, x minus 3 squared. So if you read this question, now shift the graph of the parent function 3 units to the right. Okay, like here. So in general, we can generalize in this way. This inside is plus C, that means shifts left. If this is negative, then shifts right. Shifts right. Okay. Now compression, like here is a graph. Compression means we are gonna do just the horizontal compression. Compression means you are pushing. Okay, just push. So you are applying force like that, shrinking, making it smaller. So we are only working with vertical shrink and vertical stretch. Stretch means we have y-axis, we are pulling on both sides, moving like this. Okay, stretching. Shrinking means we are just making like in this way. So here is the parent function, it's the v, that means the absolute value of x. This is y equals absolute value of x. If we multiply by a number outside, that means y coordinates will be 3 times, like we get this. So this is absolute x, this is 3 times absolute x. So this is like we are pulling the graph. Okay, so this is stretching. So we are pulling up, down. So stretch. The transformation function, this one, the function y equals 3x, okay, is the graph of the function is stretched 3 units by a factor of 3, maybe that's better. Stretched by a factor of 3 of the graph of the parent function y equals x. Okay, in the same way, if this number, look at the outside number, is this is bigger than 1, 3 is bigger than 1, that's why this is stretched. But if that number is like a 1/2, okay, outside, then that's like pushing the graph in this way. Okay, compression. The transformation function is the compression, okay, by a factor of 1/2. In this case, the transformation is stretch of the graph by a factor of 3. Now, so we want to generalize. We have a function fx, we multiply by a number outside. If k is bigger than 1, that means we are like moving this, stretching. And if this k is positive but less than 1, that means we are just pushing this. So we are compressing the graph. So compression. Okay. Now we have a graph and we want to reflect. We got x-axis here. If we reflect this about x-axis, then we're gonna get this graph. So this is square root of function. So it's below x-axis minus square root of x. Okay, so that will be the case. So here's a negative square root of x. That will be reflection about the x-axis. So negative outside of function means reflection about the x-axis. In the same way, we have this original graph, we can reflect about y-axis. Okay, that means this is the new graph. So we put the negative inside. So we have a square root of x, put negative inside of square root of x. That's the reflection about y-axis. The transformation function is reflection about the y-axis. Okay, so just write down here the transformation negative fx. That's the negative of function is reflection about the x-axis. Negative inside of the function is reflection about the y-axis. Okay, so here is a function. So I change a little bit. This is square root of x minus 8. This is a function. Let me write in this way: negative square root of x minus 8 minus 1, and this is y equals square root of x. That's the parent function. So we need to list the transformations from here to here, from square root of x to square root of minus square root of x minus 8 minus 1. So you can just list a couple of these like this way. So first we can work with negative outside. So we start with x and negative of x. That means what? Negative outside of a function means reflection about x-axis. We just did that one, negative outside. So reflection about the x-axis. Then minus 8. So then minus inside minus 8. Inside means it's a horizontal shift. Minus 8 means shift right. Okay, so from here to here, once we reflect about the x-axis, now shift 8 units right. Okay, and from there now we get x minus 8, then minus 1 outside. That means whole graph is shifted now 1 units downward. From here to here, shift downward 1 unit. So from this graph to this graph, to produce this graph from this graph, we've done 3 transformations here. Negative outside, reflection about the x-axis, minus 8 inside. Okay, shift 8 units right, then minus 1. Generally we read from left to right, so negative outside and keep going, working on inside. Now here is another example here. We got a point negative 2, 5 on the graph of fx. List the transformations and find the coordinate point on the graph of this. So we start with fx and then we'll list this point later. Okay, this is 2 times f of x plus 6. So let's do this first. So inside, and then we multiply by number later. Okay, so f of x plus 6, what will be this? Plus 6 inside. So here to here, shift this whole graph 6 units to the left. Shift left 6 units. Okay, then it's given that from here to there now 2 times f of x plus 6. So the graph we multiply by 2. Multiply by 2 means we stretch. So we just put force. Okay, we stretch by a factor of 2. So here to here, stretch, vertical stretch, okay, vertical stretch by a factor of 2. Vertical stretch means we multiply the y coordinate by this number 2. Now we describe the transformations. How about this point now, negative 2, 5? So negative 2, 5, if this point lies on the graph of fx, shift left 6 units. So if we shift this left 6 units, what we're gonna get? Left means just the x-axis, right? So negative 2 is the x-axis. We are moving 6 left. I mean, y remains the same. So negative 2, move left 6 more units. So negative, another negative 6, so negative 8. Then from here to here, now we do a vertical stretch by a factor of 2. That means we multiply y coordinate. Vertical means y coordinate by 2. So that will be negative 8 times 5 times 2, 10. So this will be the point, final point. This will be the point on this graph. Okay. And the last example here is we have a graph of y equals the absolute value of x. Now we need to apply these 3 transformations. Then find the function. Then we want to write down the function. Okay. So first off, let's say here shift right, reflect about the x-axis. Sorry. So reflect about the x-axis. That means negative outside. Okay, 1 from the given parent graph. Then shift right 1 unit. So right left means inside. So negative x plus 1 would shift left. Okay, here look, shift left plus means so minus 1. That means we are shifting this 1 unit right. That's number 2 transformation here. Now shift up 2 units. So plus 2. Then from here, negative x minus 1 plus 2 outside means we are shifting the whole graph 2 units up. So this is the answer we're looking for. So the new graph is negative x minus 1 plus 2. Okay, and that's it. For more examples, you can go to my website and try examples there, www.coastal.edu/rdahal, DAHL, math 135.